My name is Brian Wallace. I'm a principal engineer with Cisco focused on programmability and telemetry. So in the demo today, we're going to show a few things, controller to network element integration. Then we'll go through and show a NETCONF network-wide transaction touching multiple devices. We'll show how we use NETCONF to do device manageability, and then show the management of multiple overlapping services instances within the network.
Thanks, Brian. My name is Sven Wysotsky. I'm working as a PLM for NSP in Nokia, and I'm looking after automation frameworks. Talking about the test setup, what we are seeing here inside our demo is we have a network which consists of 3 Cisco XRV devices, and then what we will do is we use NSP to provision services on those. So what we will see in the demo is that we provision both layer 2 and layer 3 VPN services, including the infrastructure that is required to build those services, which includes BGP, it includes ISIS, it includes BFD, MPLS, and we actually have 2 cases. In one of the cases, we are using LDP, and in the other case, we are using segment routing. What we don't have in the demo is the traffic generator, but we will show you that the services are up and running. And with that, I give back to Brian, who will show the Cisco devices.
We look in router 1, do a show run verse. We'll show that there's no verse existing, and then we'll do a L3VPN configuration from the NSP controller.
Okay, so at the moment, no configuration is on the routers. So what we will do first is we will basically first deploy the infrastructure to build those services. To do so, we have prepared here some infrastructure intents for those Cisco devices. What we will do over here, so we have prepared configurations for the R1, R2, and R3 router. So let's go into it. So at the moment, I will disable for the first test case segment routing. So in this case, we will just roll out MPLS LDP based configuration. So I will push the service on all the 3 routers. So I start with router 1. So same I will do on router 2. And as well, we push configuration on router number 3. So let me hand back to Brian, who will show that basically BGP, ISIS, and MPLS are all up.
So if we go back to the router now, we can see that L3VPN instance has been configured.
The VPN is not yet. Huh? So it's just the infrastructure. So you should be able to show the last commit, and you should be able to show that ISIS adjacencies are up, that BGP is up, and that MPLS is up, and that BFD is up.
Let me just copy and paste these real quick.
Okay.
Ready?
So I think we should be ready now to show service configuration. Okay, so as the infrastructure is now configured, let's configure intents or layer 3 VPN services using the intent manager. So let's first have a short look into the configuration template that is used for that service configuration. So we can see that the configuration consists of 3 parts. There is one part which belongs to the actual VRF using Cisco models. Then we have a BGP related configuration as well using Cisco models. And finally, we add the interfaces for those VPNs, again, using Cisco models. To push the services, we have prepared already the configuration. So let's go into it. So we start to provision a single VPN called Blue. So let's first look into the details of that service. So the service gets deployed on 2 routers, router 1 and router 2. It uses a certain route target, MTU size, and so on. And then let's have a look into the details of that service. So we can see that we are configuring a loopback interface as well as an access interface into that service, both associated with an IP address. Similar ways, we have the other end of that service, which has another loopback interface, which we also can use then for double checking connectivity between the two sites. And also we see an access interface gets configured on the second gigabit Ethernet port of that router. So let's push that service definition. So I basically change the service state from not present to active. I update the service configuration, and with that, the service gets rolled out to the devices. And with that, I hand back to Brian.
So if we look in router 1, you can see the changes that were pushed down to the router via NETCONF. If we go ahead and look, we see configuration now for the VERF. We see VERF blue, it's RD and route targets. Look from an interface perspective, we now see that GigE002 is in VERF blue. If we look at from a BGP perspective, we now see routes being advertised in the VPN-v4 unicast address family to our peer. And if we look in the routing table for VERF blue, we see the segments from both sides of the network. In PLS forwarding, now we see LDP labels for the other two routers. And if we do a ping from VERF blue to 40, we have reachability across the L3VPN.
Okay, that sounds great. So what we will do now, so I've prepared two more VFs in the configuration here. So there's a VRF called green and another one called pink. So in this case, the difference between those is basically that we are adding more interfaces in to it. Basically, the second service, green, uses the interface 03, again with an IP address. And for the loopback, I'm basically using the same IP addresses that we have seen before. But because they are in a WAF context, they can be overlapping anyways, right? Of course, things like route targets and route distinguishers are different for each of the services. So let me activate the service green. Oops. I guess I need to fix that. Okay, so let me fix that fast. So we changed the IP addresses of those nodes. So I need basically to, so that's 2.2.2.2. Update. And here we also need to fix that one. Update. And now I push that service configuration to the network. Guess I also need to fix that one. Yeah, but we can make that quick. So here we see same service configuration on that service, just a different IP interface. Let's push it to the network too. And with this, I give back to Brian that he can validate connectivity for the VRFs green and pink.
Okay, so if we look back in the router now, we can look for VERF green. It exists in router 1. We look at the routing table now, we see 40.40.40.32 in that VERF. So if we ping across VERF green, 40.40.40.40, we have connectivity.
Next I will do is I will remove the VRF green. So currently it's active, and to remove it from the network, I turn back the state of that service from activate to not present. So I update the service configuration. So now the change should be deployed in the network, and I hand back to Brian
So now if we look in the verse that are present in router 1, we just see blue and pink. Deleted verse green. If we look at the last committed changes via NETCONF, we see that verse green was deleted as well as the interfaces associated with the verse and the BGP configuration associated with the verse.
So what I will do now is I remove more services. So let me remove the 2 remaining VFs, blue and pink.
Now, if we look in the router, we have no verse. And if we look at the commits, for the last 2, we've deleted verse blue, verse pink, the interfaces associated with those 2 verse, as well as the BGP configuration associated with both verse blue and verse pink. Okay, so if we look in the router now, we see show segment routing, hearing interfaces, we see those up. And then from a show MPLS forwarding perspective, we see both prefix SIDs associated with the loopbacks, as well as JCC SIDs associated with the router-to-router links.
So we will now use that configuration to configure EVPN services. So in this case, it's a cross connect. So again, I have prepared 3 services for that. We can see in this case, we are cross connecting site A, router 1, site B, router 2, gigabit Ethernet interface 2. And also we provide an EVI ID and a description for that service. So to activate the service, I basically flip the state here to activate. And now I hand back to Brian.
So now if we look in the router, the Sure and L2VPN, we see the configuration associated with the L2VPN cross connect has been pushed. If we look at the status of the cross connect itself, we see it's up on both ends. And we can also see the individual VPN prefixes being associated within BGP.
We will now push 2 more services to the network. The E-line called pink on the Fort interface. Giving back to Brian.
So looking in the router, we see configuration now for 3 different cross connects, blue, pink, and green. Then if we look at the operational state of the cross connects, looks like blue is up, pink and green are down.
So same as before, we now remove the second VPN, VPN green. So I move that to not present. And I give back to Cisco for short validation.
So now if we go back and look at the configuration in the router, we see blue and pink, but the cross connect for green has been deleted. Look at the configuration changes that were pushed. We can see for the L3VPN, we deleted the text connector called green.
And I think now we are ready to remove the rest of the configuration. I basically remove blue. Also remove pink. And to clean up the entire network, we will also remove the infrastructure that we pushed at the very beginning. Oops. And with this, I finally hand back to Cisco.
If we go back to the router, we'll see that there are no longer any bursts associated with L3VPN. There's no L2VPN cross-connect configured anymore. And then if we look into the Empress side, we see no ISIS, the MPLS with no LDP present. Last but not least, the V4 interfaces now are all back at the default berth.
Okay, so let's close the session. What we have seen in the demo is the creation and deletion of Layer 2 and Layer 3 VPN services. We started with the creation of the infrastructure, including all the interfaces, ISIs, BGP configuration, BFD, and we started with MPLS LDP for the Layer 3 VPNs. Then we created one service, two more services, and we removed one after another. And then in the second step, we basically created Layer 2 VPN services over segment routing. So for that, we basically enabled on top of the existing infrastructure segment routing related configuration. And then we created multiple services one after another, and we removed them as well. And finally, we have seen that the configuration of the devices ended up to be the same as we actually started with. Thank you for viewing that demo. We hope you enjoyed it, and talk to you next time.